So first we have to write what are the rated conditions they have given. The rated conditions are VR is equal to VAR is equal to 220 volt. Okay, we can write VR is equal to VAR because it is a separately excited DC motor. Okay, then they have given IAR rated current is equal to 500 ampere, rated speed NR is equal to 600 rpm, okay, which we can convert into omega mr by multiplying nr by 2 pi by 60. Okay, so 600 into 2 pi by 60, 60 ones are 60 tens are is equal to, we can write 20 pi. Okay, and its unit will be radian per sec. Next they have given the armature and field resistance of 0.02 and 10 ohm respectively. Means what? Ra is equal to 0.02 ohm and Rf is equal to 10 ohm. Okay, this data they have given. Again they have given the load torque is given by the expression TL is equal to 2000 minus 2n Newton meter. Okay, this data they have given, and they ask okay, first they ask calculate motor terminal voltage V1 is equal to VA1 is equal to what for armature, and also they have asked for calculation of armature current when the speed is okay n1 is equal to 450 rpm. Okay, this is the first case they have asked. Okay, we will solve first case. Okay, we know that if the speed is less than rated speed, okay, then it is a armature voltage control method. Okay, and for armature voltage control method, to change the speed, okay, or omega m, we have to change armature voltage V. Okay, and during this the field current IF will be unchanged. Okay, unchanged or constant. Okay, means what? Phi, sorry, flux phi is also constant. Okay, means what? During this operation phi 1 is equal to phi r. Okay, and it is constant. Okay, so now we can solve the problem. Okay, first they ask for terminal voltage. Okay, VA1 is equal to EB1 plus IA1 RA. Okay, value of RA they have given, but IA1 and EB1 they have not given. Okay, I will give it equation number 1. So the unknown quantities we will calculate. We know that EB1 is equal to KE phi 1 omega m1. Okay, similarly EBR is equal to KE phi r omega mr. Okay, this both gives the ratio EB1 by EBR is equal to KE phi 1 omega M1 divided by KE phi R omega MR. Okay, we know that the flux during the armature voltage method is going to be constant, therefore they will get cancelled. Okay, so we'll get the ratio EB1 by EBR is equal to omega M1 by omega MR. Okay, or we can write it as N1 by NR. Okay, because we are taking ratio. So we to calculate EB1, we have to calculate EBR first. I will give it as equation number 2. So EBR is equal to VAR minus IAR into RA, where VAR is given equal to 220 volt minus IAR they are given equal to 500, and the armature resistance RA they are given equal to 0.02, and we have calculated it. EBR is equal to 210 volt. Okay, once we have calculated EBR, now we can go for EB1. From equation 2 we can write EB1 is equal to N1 by NR into EBR. Okay, what I did, I just shift EBR to other side. So in this case, for first case, the N1 is equal to 450 RPM divided by NR is equal to rated speed is equal to 600 RPM, and now we have calculated rated back EMF which is equal to 210. Okay, this will lead equal to, I will use calculator, 450 into 210 divided by 600, 157.5 volts. Okay, this is the EB1. Now we can calculate the V1. We will check whether we can calculate. V1 is equal to, again I will write the equation EB1 plus IA1 RA. Okay, so in this equation we now calculated EB1, but still IA1 is unknown. Okay, so to solve this we have to calculate IA1 first. Okay, obviously the IA1 terms comes in other equation of torque. Okay, T1 is equal to KE phi 1 IA1. Okay, in this equation IA1 is present. Similarly, TR is equal to KE phi R IAR. Okay, so the ratio will be T1 by TR is equal to KE phi 1 IA1 divided by KE phi R IAR. Okay, again for armature voltage control method, phi 1 is equal to phi R, so these two terms get cancelled and we get the equation T1 by TR is equal to IA1 by IAR. Okay, I will give this as equation number 3. So we know the value of IAR, but T1 and TR are unknown. Okay, we have to calculate those first. Okay, so they have given equation. Okay, whether we can use that equation or not, we don't know. Okay, TL is equal to 2000 minus 2n. Okay, this equation they have given. this equation we can use to calculate torque. Okay, but the rated torque cannot be calculated using this equation. Okay, rated torque cannot be calculated using this equation. Rated torque means what? The rated or maximum torque the machine can produce. Okay, and obviously the torque developed by the machine must be more than the loaded torque. Okay, by which amount? By the amount equal to j d omega m by dt. Okay, so we can write that TR is always equal to TL plus j d omega m by dt. Okay, means what? TR is always greater than TL. Okay, this condition must always be there. Okay, okay, so that the machine will run. Okay, so we can't use this equation TL is equal to 2000 minus 2n to calculate TR. Okay, to calculate TR we can't use this equation. So I will write that equation of TR once again. TR is equal to KE phi R into IAR. Okay, so we can't use the ratio T1 by TR to calculate TR. Okay, so we have to check for whether other quantities can help. Okay, so in this case EBR is equal to KE phi R into omega mr. Okay, we know the value of EBR, we know the value of omega mr, IAR is given. Okay, so we can calculate TR. Okay, by taking the ratio. Okay, so TR by EBR, 1 minute, please turn off your video. Okay, Navnath Khatar, video band kara. So the ratio TR by EBR is equal to KE phi R IAR divided by KE phi R omega mr. Okay, again these terms will get cancelled. Therefore TR by EBR is equal to IAR by omega mr. Okay, therefore TR is equal to IAR by omega mr into EBR. Okay, IAR they have given equal to 500, omega mr, okay, they have given, sorry, we have calculated. Okay, omega mr we have calculated because they have given the speed in RPM, and for this equation we have to take omega mr in radian per second. We have calculated it. Okay, it is equal to 20 pi here. 20 pi. So 500 divided by 20 pi. Okay, when ratio of same quantity is there, okay, we can take different units. Okay, but the unit of numerator and denominator must be same. But here the ratio of different quantities, we are taking ratio of different quantities. IR's unit is ampere and omega mr's reading unit is radian per second. So we have to use radian per second in this case. 500 divided by 20 pi into EBR is equal to 210. Okay, so it will give 500 into 210 divided by 20 divided by pi is equal to 1671.13. Okay, 1671.13 Newton meter. Okay, this is the rated torque. And now we have the value of rated torque TR. Okay, so we will check whether IA1 still can be calculated or not. Okay, observe this equation. Okay, in this equation now TR is, we have calculated, IR they are given. Okay, but still T1 is unknown. Okay, to calculate T1, okay, to calculate T1 you can use this equation. You can use equation. Why? Because in first case what they have said, okay, I will reread for you. Okay, read it carefully. Okay, what they have told: calculate motor terminal voltage and armature current when the speed is 450 rpm. Means what? The machine is running with a constant speed of 450 rpm. Okay, means what? Machine is continuously running with a speed of 450 rpm. So when the machine is running with a constant speed, the electromagnetic equation, the fundamental electromagnetic equation will be equal to, I will show you. Okay, always if the motor torque is T1, okay, in first case the motor torque is T1, which is equal to TL plus J d omega m1 by dt. Okay, but speed is constant, means what? The derivative of constant will be 0. Okay, so in this case T1 is equal to TL. Okay, so we can use the equation of this load torque. Okay, to calculate rated torque we can't use, because the rated torque is always greater than the load torque. Okay, जर ते लोड टॉर्क पेक्षा जास्त नसेल रेटेड टॉर्क तर मशीन तुमची स्टार्टच होणार नाही. ओके, मात्र मशीन ज्यावेळी एकदा कॉन्स्टंट स्पीडने रन होत असेल, ऑब्व्हियसली मी आपण म्हणू शकतो मशीन इज इन स्टेडी स्टेट. आणि ज्यावेळी मशीन कॉन्स्टंट स्पीड किंवा स्टेडी स्टेट मध्ये असेल त्यावेळी मात्र लोड टॉर्क इज बॅलन्स्ड बाय दी मोटर टॉर्क असं म्हणू शकतो. आणि त्या केसमध्ये T1 इज इक्वल टू TL असेल. सो वी कॅन यूज द इक्वेशन ऑफ लोड टॉर्क इन दिस केस. Since T1 is equal to 2000 minus 2N1, 2000 minus 2N1. Okay, they have given equation in terms of N. Okay, N, and unit of N is RPM. Okay, unit of N is RPM. So T1 is equal to 2000 minus 2 into N1 is 450. Okay, is equal to 1100 Newton meter. Okay, now we have torque, so we can calculate current now. The ratio T1 by TR is equal to IA1 by IAR. Okay, therefore T1 is equal to 1100 divided by TR is equal to 1617.13 is equal to IA1 divided by IR is equal to 500. Okay, therefore IA1 equal to 1617.13. 1 minute. Okay, 1100 into 500 divided by 1671.13 is equal to 329.12. 329.12. Okay, ampere. This is the correct answer. This is the correct answer. Okay, do you get it? सगळ्यांना कळालं कसं केलं हे करंट कसं कॅल्क्युलेट केलं. रेटेड टॉर्क कॅल्क्युलेट करण्यासाठी लक्षात ठेवायचं की रेटेड टॉर्क इज ऑलवेज ग्रेटर दॅन दी लोड टॉर्क For that, we have to use equation TR is equal to KE IR IAR. Okay, but for a given constant speed, okay, torque, motor torque is equal to load torque. तर IA1 मिळाला, आता आपण VA1 कॅल्क्युलेट करू शकतो. Therefore, VA1 is equal to EB1 plus IA1 RA. EB1 आपण वर कॅल्क्युलेट केलं तर किती आहे बघा. EB1 आहे 157.5. प्लस IA1 आताच कॅल्क्युलेट 329.12 into RA they are given equal to 0.02. 329.12 into 0.02 plus 157.5 is equal to 164.08. 164.08. Okay, now we have solved first part. This is the first part of the problem. Now we will proceed for second part. I will shift the problem to this side. Okay, now the second part. काय डाउट असतील तर विचारा. Second part, what they ask, calculate field winding voltage VF is equal to what, and armature current IA2. Okay, I will write here VF2 and IA2 is equal to what, when the speed is 750 rpm, N2 is equal to 750 rpm. Again we can calculate omega M2 is equal to 750 into 2 pi by 60, which is equal to 25 pi. 25 pi radian per second. Okay, they ask for what, field winding voltage and armature current. So to calculate field winding voltage, okay, obviously we have to calculate first what is the sorry, they have also asked for armature current. Okay, okay. First we will calculate the armature current and then we will go for field winding voltage. Okay, because obviously for in this case, okay, we can see that the field winding voltage, or I will draw the circuit diagram of separately excited DC motor once again. This is the armature part. Okay, if the time ends, then we will extend the lecture for 10 more minutes. Okay, I will send the link once again. Okay, after 10 minutes we have to end this problem today itself. Okay, this is the armature circuit and this is the field circuit. Okay, so from this we can observe that, okay, suppose this is the field voltage Vf, this is the field current If, and suppose because of the field winding, flux produced is phi f. Okay, or just phi. Okay, just phi. Then we can say that the phi proportional to If. Okay, but If is equal to Vf by Ref. Okay, means what? Therefore phi proportional to Vf. Okay, means what? To calculate field voltage, okay, we have to calculate phi. Okay, means what? Again we have to go for ratio. Okay, means because the value of phi is not given. Okay, so to calculate Vf we have to go for Vf1 by Vf2 is equal to phi 1 by phi 2, like that. Okay, one of these cases we can take as a Vf1, we can take, instead of Vf1 we can take Vfr. Okay, and instead of phi 1 we can take phi r. Okay, and then we calculate Vf2, okay, for known phi 2. Okay, so why instead of Vf1 I have taken Vfr, or instead of phi 1 I have taken phi r? Okay, because the final point of the armature voltage control technique, okay, the final point of armature voltage technique is the initial point of the field control technique. Okay, means what? The one point is common between armature voltage technique and the field current technique. Okay, one point where the speed is rated. When the machine is running on the rated speed, that was the starting point for the field control technique, but that was the end point for the armature voltage technique. Okay, means what? The when the machine is running with the rated speed, we can say that that is the common point between both these control techniques. Okay, so to calculate the field voltage we have to calculate flux. We will see how we can calculate that thing. So this equation Vfr by Vf2 is equal to phi r by phi 2. I can rewrite that equation like this. Vfr by Vf2 is equal to Ke phi r by Ke phi 2. Okay, what I did, I just multiplied numerator and denominator by a constant K. And now we can calculate Ke phi r or Ke phi 2 from the equation of torques or from the equation of back EMFs. Okay, so in this way we can calculate field voltage. Okay, Vfr by Vf2 is equal to this. So for example, to calculate Ke phi r, okay, that was present in equation of torque as a T is equal to Ke phi Ia. Okay, for that we have to calculate current Ia in this case. Okay, so in this case the T2 is equal to, okay, the speed they have given equal to 750 rpm, means what? The machine is running with a constant speed of 750 rpm. Okay, so we can use the equation of load torque. T2 is equal to 2000 minus 2n2 is equal to 2000 minus 2 into 750 is equal to 500 rpm. Okay, sorry, 500 Newton meter. Unit of torque is Newton meter. The equation, this question I have asked in the MCQ. So now we have to proceed to calculate current. Okay, for that we can use the equation. For example, VA2 is equal to EB2 plus IA2RA. Okay, but for that we have to calculate EB2. Okay, we have to calculate EB2. Okay, so we can rewrite this equation. Equation number, I will give equation number 1. Okay, because it is a second part. What is the value of VA2? Okay, they have not given the VA2, but since during field control technique, the voltage rate across armature is maintained constant, which is equal to rated voltage. लक्षात ठेवायचं, आपण फील्ड कंट्रोल टेक्निक साठी सॉल्व्ह करायला लागलोय. फील्ड कंट्रोल टेक्निक साठी आर्मेचर सर्किट मध्ये काही चेंजेस करायचे नाही, रेटेड कंडिशन्स मेंटेन ठेवल्या पाहिजेत. ओके, मीन्स व्हॉट रेटेड armature voltage equal to rated voltage means what? VA2 is equal to VR. Okay, means VA2 is equal to 220 volt. का घेतलं लक्षात ठेवायचं, हे वाटलं तर ते लिहितो मी. फॉर field control technique, VA is equal to VAR. लक्षात ठेवायचं. Therefore 220 1 minute. Okay, 220 is equal to EB2 plus IA2 RA. RA they are given equal to 0.02. So instead of EB2 we can rewrite as, since EB2 is equal to KE phi 2 IA, sorry, KE phi 2 omega m2 omega m2. Okay, I can write like this. Okay, again we know that T2 is equal to KE phi 2 IA2, KE phi 2 IA2. Therefore KE phi 2 is equal to T2 by IA2. Okay, we have calculated T2 is equal to 500 divided by IA2. Now we have the value of KE phi 2. So we can write EB2 as, therefore EB2 is equal to 500 divided by IA2 into omega m2. कळलं का बघा, या KE phi 2 जे आहे त्या ठिकाणी मी काय टाकलं, KE phi 2 ठिकाणी हे इक्वेशन टाकलं, 500 by IA2 into omega m2. Okay, which is equal to 500 divided by IA2 into omega m2 is equal to, we have calculated, I think it is equal to omega m2 25 pi. Okay, you can observe here 25 pi. One minute. Where is the problem? Okay, into 25 pi. Okay, this is the value of EB2. Now we can we can place this value in equation 1, so we can get, 1 minute, what happened? Okay, so we have to write this value in this equation. 220 is equal to EB2 means 25 pi into 500 divided by IA2 plus IA2 RA is equal to 0.02. Okay, we can multiply IA2 by with both sides. So 220 IA2 is equal to 25 pi into 500 plus 0.02 into IA2 square. Okay, therefore 0.02 IA2 square minus 220 IA2 plus, okay, I will solve that third part. 25 into 500 into pi is equal to 39,269.91. 39,269.91. Okay, this is the quadratic equation is equal to 0. This is the quadratic equation. We can solve this, or anyone have a calculator with facility to solve such a equation, please solve for me. कोण सॉल्व करू शकते का बघा कॅल्क्युलेटरवर, नाही तर ऑनलाईन करावं लागेल मला. तसं कॅल्क्युलेटर माझ्याकडे नाही येते. कोणाला आहे का? In this lecture we will solve just IA2. Remaining part we will see in next lecture. Online quadratic equation solver. Okay, you have to write in, if the equation in the form ax square plus bx plus c, then just we have to write the coefficients here. First is 0.02, 0.02. Second is minus 220, minus 220, and third is 39269, 39269.91. 90. Solve. Okay, these are the values. First is the 10,818. So IA2 will either equal to 10,818.51, or IA2 is equal to 181.49, 189.49. Okay, which is the feasible value? Obviously 189.49 is the feasible value. Current never goes, okay, motor current never goes 10,000, okay, value equal to 10,000. It will be 189.49 ampere. Okay, this is the feasible value. Okay, then we have calculated the half part. Okay, the value of IA2 we have calculated. Now we require the value of field voltage. Okay, so to calculate field voltage, what we have seen, 1 minute. Okay, Vf is proportional to pi. Okay, I will draw the field circuit here. Okay, this is the field circuit. To change the value of pi, okay, we require a variable field voltage. Okay, variable field voltage Vf. Okay, means what? To change the pi we have to change field voltage Vf. Okay, so we can write like this. Okay, Vf, when the voltage is Vfr, okay, rated field voltage is there, then in that case the flux is pi r. Okay, and if the voltage is Vf2, okay, Vf2 is corresponding to speed requirement of 750 rpm. Okay, then suppose in that case the flux is pi 2. Okay, so I can write that Vfr by Vf2 is equal to pi r by pi 2. And we know that, okay, we know that the point Vfr and phi r, okay, this point, okay, these 2 points are common in armature voltage control and field control technique. Okay, this is the final point. Okay, or we can say that this point is constant throughout the operation of armature voltage. Okay, and it is going to be reduced in case of field control technique. Okay, means what? We can say that this is the final point in the armature voltage control technique and the initial point in field control technique. Okay, so this can be written as, okay, I just multiplied numerator and denominator of right side. So 1 minute. Okay. By Ke, okay, we can write that Vfr by Vf2 is equal to Ke phi r by Ke phi 2. Okay, Ke phi r by Ke phi 2. Okay. We have to consider, okay, what will be the value of Vfr. Okay, in the problem the value of Vfr, rated field voltage, is not given, so we have to consider the rated field voltage Vfr is equal to rated armature voltage VAR is equal to 220 volt. We have to consider that. Okay, if they have given it, then we have to take that value. Okay, if it is not given, we have to consider VFR or rated field voltage is equal to rated armature voltage. So in this equation, I will write this as equation number, I think, 3. Okay, VFR is known. Okay, VF2 has to be calculated. Okay, and for that we have to calculate first what is the value of Ke phi r and what is the value of Ke phi 2. Okay, so we know that Ke phi r can be calculated using the equation of EBR. EBR is equal to Ke phi r omega m r. Okay, therefore Ke phi r is equal to EBR divided by omega m r. Okay, where EBR we have calculated, which was equal to 210 volt, and omega m r they have given equal to 600 rpm, and obviously it has to be multiplied by 2 pi by 60. Okay, so it is equal to 210 divided by 60 ones are 60 tens are 20 pi. Okay, which is equal to, okay, I will use calculator. To 10 divided by 20 divided by pi equal to 3.342. 3.342. 2. Okay, now we have the value of ke phi r. So now we have to proceed to calculate ke phi 2. Ke phi 2. Okay, so for calculation of ke phi 2, you can use either of these two equations. Okay, eb, okay, we can eb2. Okay, I will write here, and why we can't use this equation. Eb2 is equal to ke pi 2 omega m2. Okay, as the value of eb2. Okay, uh, or eb2 is equal to ke phi 2 omega m2, or we can use this equation. T2 is equal to ke phi 2 ia2. Okay, to use the eb2 is equal to ke phi 2 omega m2, you have to calculate eb2 first. Okay, and for given omega m2, you can calculate ke phi 2. Okay, but we already calculated t2. Okay, we know we have calculated the value of ia2, so to use the second formula is easier. So we will use this formula of t2. Therefore ke phi 2 is equal to t2 by ia2, which is equal to t2 we have calculated equal to 500, and ia2 we have calculated is equal to 181.5. Okay, I will show you. Okay, this is the ia2, and to calculate t2 we have used the load torque equation. Okay, here is the t2, this is the t2. So to calculate t2, sorry, to calculate ke phi 2, what are the quantities which are already calculated, we have to use those. Okay, so it is equal to 500 divided by 181.5 is equal to 2.755. 2.755. So we have ke phi 2, ke phi r. Now we can calculate vf2. So again, vfr by vf2 is equal to ke phi r divided by ke phi 2. Okay, vfr we have assumed equal to 220 volt divided by vf2 is equal to ke phi r we have calculated, which is equal to 3.342 divided by ke phi 2 is equal to 2.755. Okay, therefore vf2 is equal to 220 into 2.755 divided by 3.342, which is equal to 220 into 2.755 divided by 3.342, 181.36. 181.36. Okay, in chat box. Bhagyesh rate is 181.36. Okay, So now we have calculated, we have 2.